Okay, wait, never mind. Okay, like that.
On the table.
In another class, right, we put it normally beside that. Somewhere there where cutting is. And then it's not too bad.
Here can see, like,
Wait, but Sophie have to like
no.
permanently tilt her body.
No, cannot see her lah. She sit normally cannot see. So tiny.
Okay, we'll be continuing on with lesson yesterday. When we stopped off for the worksheet. I trust Zen has been reminding you of
I spend.
spam.
That's why.
What about your other subjects? Do you have someone to spend your?
No, only I spend.
You elected your class meeting? Yeah. Right. Okay, then who's the class chair? Okay. Good. Who's the device? The research device. What was it you're trying your project just now? It looks so nice. Oh, you made it? Can I see it? Yeah, I can tell. Even from far.
Exactly.
Okay, then vice chair. Then who's the secretary? Secretary. Then you're treasurer. Okay, you know what's your job or not? Oh. Okay, good. Why all girls are? Oh. Huh? Cyber wellness ah? What's your job scope? What's your job scope? No job. Is that why you volunteer? Was this like voted on? Oh, you know, okay, then what else ah? You're any ambassador. They really are all females ah? Yeah, what's the BIA? Unrun. Good.
That's all good.
All good. Hey boys. What about the subject reps? Have you all been chosen?
What? Yeah.
Have subject reps have been chosen? Okay. So other than Zen, who else are the subject reps? Ah, okay. Man. Sorry? What? No, I know you're England. LA, okay. Xavier, you're what? What is your full review?
That's all good.
That's what I know, right, Xavier?
Lucia? What are you?
Geography.
Sorry?
Geography.
Geography, okay. I saw some hands raised here. Yes. Hausen.
Tyson.
Tyson.
Cucumber.
History.
I just remember.
Who? Oh,
Samuel also.
Samuel. Samuel, you are right, what rep? Any rep? E rep. You're going to be E rep, Samuel. Okay, good. Okay, shall we continue with the next? May I prepare the worksheet? You are asked to do the second part of the worksheet.
It's a tie. It's a freaking tie. Look,
It has no stable intelligence.
it's a tie. Wait, you don't play?
If I was to even have
Hey, who's the Iron Man? Iron Man, oh my god. Iron Man. Okay. Okay, I'll push it the black. Oh, you know what is this?
I like this.
Say you already started recording. So I'll check the video quality.
What? Can see what? I only see you and you.
I have to put it on the table. So what is that?
Oi, oi, oi.
Why don't you just put it on that table?
It's too high.
Then tilt it downward.
I am too high.
Huh?
Alright, let's go to the second part of the worksheet. Yesterday we talked about similarities. Today we're going to talk about some of the differences that you identified between viruses and living things. Then we'll end off. We'll have a discussion about whether viruses are living things or not, based on all the work that you have done so far. Okay, let's listen from some of you. What are your points of comparison down in the middle, and how do you compare after you listen the pointers? Okay, so you have a look at your worksheet, consolidate your thoughts, then I'll listen to some of you as well. You have not heard for in a while. Okay, let's listen to Ananya. Ananya, I listen to you a lot already. Okay, you take a break, then I listen to your other friends first. Okay, could I listen to Amy? Maybe I just call you recently. But I just let's do it again. Amy, will you share one point of comparison? Okay, speak loudly so that you don't need to repeat yourself. Okay, that was like this point, right? Whether they are made of cells. What about your own? Whether they meet? Okay, so thank you, Amy. Amy says, whether they need energy to survive. That's what she compared in the middle. What do you say on both sides? Okay, so one is for viruses, one living things. What do you say? The viruses don't need energy to survive. And living things is a flip one. Okay. Thank you, Amy. Okay, viruses need energy. Oh, sorry. Don't need energy to survive. And then this side is need energy to survive. Okay, what Amy has done is that she chose something to compare. And after that, she went on both sides to describe and elaborate a little bit more. Yes, survive. Thank you. Okay, thank you, Amy. Okay, let's listen to another point of comparison. Okay, we listen, Nara. Yeah. Okay, whether they can grow. Okay, I'm going to make it shorter now. Okay, whether they can grow. Okay, viruses cannot grow. Living things can grow. Okay? Okay, we pause a while. You can jot down anything new if it's new to you. Next person I want to listen to is Samuel. Samuel, you stand by, can you see whatever points you don't there? It's not a whiteboard, you can just share one. You all shared a lot already. So I need to pace you so that you have enough steam, right, for JH2, JH3 and JH4. You all are very cute one. When you go to JH2, right, like you'll be the same teacher, right, but it's like you're all different people. You all start to become very quiet. You go to JH3, more quiet. JH4, you talk more. So don't be like that, Ken. Just continue, don't be afraid of the teachers. Some teachers are a bit scary lah. Samuel? Huh? What? Never mind, you try. You cannot. You cannot. What is one point of comparison? Oh, okay. You wrote about organs. Okay, is that one of the characteristics of life? Is that one of the characteristics of life?
No.
No, okay. But I would say that when you talk about organs, it means that it's made of cells. So it kind of is on that note. Yeah? Okay. You talk about organs, so one have organs, one don't have organs. Okay. Living things, not all living things have organs. For example, some living things are just one cell and they don't have organs, right? A good try. What else do you write other than organs? That's an interesting point. Sorry? Then what about the rest? Do you write anything more? You only wrote 1 point. Only wrote 1 point. Oh, you also wrote the growth one. Okay, thanks. Thanks, Samuel. Okay, so Samuel talked about organs. Okay, but organs are a characteristic of life. But organs are made of cells. Okay, so let's listen to someone else. Ananya, okay, you really have to get out of the system. Okay, come. Okay, do they use waste products? Which characteristic of life is that?
What?
Does it fit under here? Okay, I do think one of the characteristics of life has to do with making use of materials. And I think as a result of making use of materials, you will also produce waste materials. So it could fit under that. So whether you need energy, whether you produce waste, they fit under the same category of using materials. Okay, some of you may say whether they need food or not, it kind of fits under this category. Okay. Isaac, may I hear 1 point from you if you have anything new to add? All the same. Okay. Yes. Okay, whether they can keep themselves in an internal stability there. Okay. So viruses are the ones that cannot. Then living things can. Okay, thank you. I think you have something you want to say. Anyone has anything extra that's not the whiteboard? Okay, the genetic code.
Yeah.
Okay. Then we just shared that the genetic code that living things have is DNA inside the nucleus. We do have some RNA, you will learn next time, but it's not part of the nucleus. Viruses are interesting. Viruses can have RNA or DNA in their nucleus. Sorry? Okay, so viruses can have RNA or DNA inside the nucleus. Do you all know what nucleus is in primary school? Oh, sorry. Yes, I shouldn't even say that viruses have nucleus. Thanks for spotting that. So viruses have RNA or DNA, not in their nucleus, just floating inside them. Okay, thanks for the spot. Thank you, that was very important. Viruses do not have nucleus. It's not.
Viruses are balloons.
Yes. viruses do not have any nucleus, they do not have any of the machinery that will allow them to reproduce by themselves. That's why they need to infect a host cell to be able to make use of all the machinery inside to create new versions of itself. Yes, Yuchong.
So the virus is a balloon.
Say again.
The virus is a balloon with genetic code.
Okay, viruses, what genetic code?
A virus. So basically, a virus is like a balloon with genetic code.
Okay, so basically a virus is a balloon with a genetic code. Yes, virus is nothing more than a package with a genetic code inside that floats around, infecting other cells so that it can make new ones. Anything else you'd like to add? I brought a model of a virus today. Yes. What do you mean?
You see that?
Oh, okay. Okay, interesting.
You can't see.
Gareth says viruses can spread, right? And we've experienced it ourselves. Hey, have you all got COVID-19 before?
Yes.
Wow, who are the super soldiers I never get before? What? You all didn't get before? Okay. Well, you are, I've never seen so many hands go up before. You are very strong, huh? First time I saw so proud of themselves of getting so many things per one go. Okay. What was that even talking about? So Gareth says, right, viruses can transmit and spread. What about living things? Can they spread?
It's a wall.
Okay. So I think Gareth, you're saying, like, for example, if I pop in your plate, I can spread virus to you, right? Could living things be spread this way? Can. So, for example, bacteria is a living thing. Bacteria can spread, right? Fungus also. You all ever get some fungal infection somewhere? That also can spread. Okay, so these things can spread. I'd like to show you a model of a virus so that you have an idea of what it looks like. Yes.
So when they like ask these questions, they use them to find the answers to all living things.
Oh, okay. Ananya asks, what if I give you this question? Sorry, Chloe. What if I give you this question in a quiz, in a test? Right? How? She's mainly asking, this living thing here, right? Do we keep it general or do we choose a particular living thing? My answer is keep it general. Okay? They are looking for all the characteristics of living things, not just of a bacteria, of a tiger or cat. Okay, today I brought a model of a virus. It's not made by me, it's actually made by your seniors many years ago. Yeah, they made this. When you go to the upper secondary side, you'll learn about viruses and bacteria. So as part of their lesson, they made a virus. I think it's very beautiful because this is quite an accurate model of a virus. Do you know that viruses are smaller than yourselves?
Yeah.
They are smaller than any bacteria. Viruses are extremely tiny. So if you think about it, if a bacteria is this big, a virus is just one dot. It's that small. Viruses are not made up of cells. They are very, very small, just contain genetic code. And a little bit more. If you look at this model of a virus, you find that it contains a lot of these spikes on the surface. Yeah? You look at your worksheet, the front page, the virus also comes with a lot of spikes. These spikes on the surface of viruses are very, it's what allows viruses to stick onto their host. Depending on what kind of spikes it has on its surface, it can stick to different hosts. So for example, some viruses maybe only infect birds. It's because the spikes on the surface can only hook onto bird cells. Every once in a while, viruses may evolve. What do we mean by when they say they evolve? You know that you've heard of COVID variants, right? So, when they evolve, this is what they do. It's very nasty. They will swap out the spikes on the surface. So you see these red ones on the surface? They could very well be, and they swap it out. They swap it out, and then instead, they maybe put a purple one. Oh, I think I just put this. Okay? And then maybe they put a purple one on top instead. But by putting different spikes on the surface, and they evolve over time, that means they can cling on to different hosts. And that's how some viruses can jump from animal to humans. is despite of the surface change. And that's also why we need to keep taking different vaccines. Because every once in a while when the spike changes, your body will not be able to detect the virus anymore. Originally, it recognized this blue spike as the virus. Over time, if it evolves and all the blue spikes turn to purple, then your immune system cannot detect it anymore. That's why we need to keep vaccinating ourselves. Yes?
Is there anything inside?
Sorry?
Is there anything inside?
So observers then looks at this virus and it looks like actually we can spray it open. And so your seniors are very good. That's why I love this particular model. They built a model right, where I can crack open like a rambutan. Okay? Very nice, all your seniors. Okay. Oh yeah, I give it back later. Inside, your seniors have put a lot of these squiggly things. What are these squiggly things?
RNA.
Yeah. Inside viruses is where you'll find the genetic code. It could be DNA, it could be RNA. And so what viruses do is this. They will find a host cell. Maybe Chloe, you are my host cell, and then the virus goes inside Chloe, and then what they'll do is they'll release all its genetic material into Chloe. Then what will happen next? It will then make use of whatever materials, whatever machine is inside Chloe to make more viruses. Once it's done, it will Chloe will explode and more viruses will come. Okay? So that's what viruses are. Every time one virus goes in, billions can come out. So can you imagine how hard it is to really get rid of the virus? Alright. Okay, so that's a quick model of a virus.
Can you pass this around?
Oh, you want to? Okay, sure.
Hey yo.
Hey, is that my okay, as you can tell, I really like Marvel stuff. The one that called just now Captain America shoot Iron Man, right?
It was made by Iron Man.
Okay, that was a
Actually,
worksheet.
clay on styrofoam.
You may file the worksheet or slot it in if you didn't bring a puncher. So that's simplify.
I dropped
Just for fun. Hey, actually we haven't answered the story yet. So is a virus a living thing or not?
No.
Okay, who says it's a living thing? Who says a virus is a living thing?
What you did?
Okay. Who says virus is a non-living thing? Many of you say it's a non-living thing. Okay, so how should we reply? Someone asks you if a virus is a living thing or not. Okay. Actually, in the scientific community, the way we reply is as such. We say that viruses have some characteristics of living things, and it has some characteristics of non-living things. And we stop there. Yeah, we stop there. Why? Yeah, it's a neutral answer, you're right, Garrett. We stop there. Why? Because many scientists believe that the origin of life actually started from viruses. That viruses over time long time ago, start to build up more parts that allow it to reproduce itself. They eventually looks more and more like a cell, such as a nucleus. So scientists think that viruses are the very early stages of life, even though it does not have many of characteristics that we would define as life. At the same time, it has too many characteristics that make it non-living. But to say it's non-living is to discredit the fact that it could be the ancestor of all life. Garrett. Someone pass you around that. So, what do you say if someone asks you if viruses are living or non-living? You say this, It's your duster, okay. Viruses have both characteristics of living and non-living things. I would say we take a neutral stance sons also because if you notice that there are quite a lot of characteristics that make it living, quite a lot that make it non-living. Yes?
Isn't the post supposed to be after
Viruses have. Oh, okay. My English is it? Okay. You're saying this should come after, is it? Characteristics of both. Is this better? Better? Viruses have characteristics of both living and non-living things. Do you find it better?
Mr. Tan.
Okay, my English. I mean, I don't know which one is better. Lah.
Oh my god.
Who's your LA teacher?
Spider-Man.
Someone. Okay.
Spider-Man.
That's Spider-Man?
No, it was from Spider-Man. Not Spider-Man. That's Green Goblin.
The yellow lantern.
Oh, yeah, that's fine. That's it.
The duster is there.
What?
The duster is there.
Oh, thanks. You solved all my problems, huh? Okay. But some things are, okay, we don't use this way of replying for everything. Because if you really look at it, look at my marker, I think it hits more characteristics of non-living than living. We can more definitely say it's a non-living thing.
Phone battery.
Well, while that is going around, I have a question for you. Is this orange a living thing?
Was.
I'd like you to think about it. Okay? Have a buzz with your neighbor, whether you think this orange is a living or non-living thing. Okay? Then we'll listen to some of you. Yeah? Okay, I'll give you the example.
Hey yo, Samuel.
Okay, I have a buzz with your neighbor. Is this a living or non-living things? And I would like you to share why you think so, based on the characteristics of living things. Question, yes? Yeah.
The orange is not a living thing, but things
Yeah.
can be.
The cells will still be there. So it has one characteristic, but everything else doesn't really. Yeah.
Depends like when did you pick it?
Sorry?
Depends like when did you pick it from the tree?
Oh, okay. Okay, let's begin our discussion. So, is this orange a living or non-living thing? Okay, let's listen to all of your points. Okay, Zen, what do you say?
Like it depends on when you pick it from a tree. It's like if it's very long ago, the cells might have all died. Then
Okay,
it's not.
Zen says depends on when you pluck it from the tree. Why does it depend on when you pluck it?
Because like it has like all the nutrients and
Yeah.
things for the cells inside to survive.
Okay, so if it's plucked, if you just plucked, it will still have in supplied nutrients. But if you leave it there for a while, then where the nutrients go?
It's used up by the cell.
Okay, maybe use some inside orange already. Okay, so it depends on when it was still connected. Okay, so the connection to the main tree, to you that is important, right? Because when you pluck it from the main tree, that means whether it's still alive. So if it's still connected, you will say it's still alive, is it? Is that? If it's still connected to the tree, to you it's still alive. But once taken away, as time goes by, you will consider it not alive anymore. Okay. There was an interesting discussion here. What were you talking about? Yeah, okay. There we have something. Don't have, okay. What was on your mind when you looked at the orange?
It's very tasty.
You want or not? It dies. You want? It's going to die soon. Okay, why you say it's going to die soon?
Because it's parents.
Okay, because it's perhaps using up the energy inside. That implies that there is something living inside. Yeah, oranges are made out of cells.
Bacteria.
Okay, they do have cells. They do have cells. Yes, Isaac?
It's living because it's not rotted yet.
Okay, it's living because?
We haven't like died yet because it's like haven't rot yet.
Okay. Oh, okay. So, sorry. A sign that something is dead when it's rotting.
No, it's rotting, it's decomposed. It doesn't necessarily say it's dead.
Fair enough, that's an interesting point. Okay, if something is dead, the reason why something that's dead will start to rot and decompose is because the immune system is no longer fighting away the bacteria. So it hasn't started rotting. So perhaps it's still alive. Okay, I like that train of thought. Okay, so remember to consider something living means it's not yet dead. So not yet rotten. Okay, not yet rotten. Okay, yes. Yeah, they die first and they rot.
Exactly.
So, is it there yet? Actually, I honestly don't know.
Yeah.
I honestly don't know if they started rotting
Yeah.
because rot starts very small. In fact, I have this one bruise over here. I don't know if it's the start of a rot. So, question mark? It's not yet rotten, but is it dead? Actually, I don't know.
No one knows.
Let me ask it. Yes, Karthik?
Yeah, exactly.
Oh, okay.
Exactly.
Karthik says it can reproduce because he has seeds. So therefore, hey, it hits the mark of a living thing. Any other points? So how is this orange a living thing or not? Yes. But can I plant your arm and then more arms come out?
Oh.
Okay, so is an orange still a living thing? When I asked this question to 105, they concluded that it has characteristics of living things, it has characteristics of non-living things. But what they felt was that kind of like what Karthik talked about, the seeds. Actually, if you zoom into the seeds are very much alive. The most alive part of a fruit, I would say, is the seed. Yeah, the seed not just is able to reproduce, not just made up of cells. Actually, a seed is still making use of nutrients.
Yeah,
You know, every seed, inside every seed comes with nutrients inside that the baby plant inside is still making use of to stay alive. That's why seeds have an expiration date. You actually cannot keep seeds forever. Eventually, seeds can die. If you try to plant a dead seed, it will not grow. So inside every fruit, there's actually a living seed. Yes? Oh, yeah. I mean, that's the thing, you never know if something's alive until you plant it. Yes?
Isn't like the seeds feeding on the nutrients, like when you eat the orange, it's like the sugary, it's like water.
Oh, okay, that's interesting. Zen asked, did the nutrients for the seeds come from the sweet part of the orange? Actually, it's not. It comes from inside the seed itself. Every seed inside, it comes with this pre-packed food.
Then why is the
So then why is the orange sweet? It's for you. So that you will eat the orange, and then you'll find some nice rice patch, and then you'll shit the seed out. Yeah? So that's what it's for. Okay, so that concludes our first part of the chapter. Characteristics of living things. Can you still remember all 8 characteristics? Okay. Okay, so flip to the page 34. Can you still remember all characteristics of living things? Because that is, we are going to close this part of the chapter. Oh, but the rest of the parts of the orange have no purpose anymore. Their only purpose is to get eaten so that this seed will. Yeah, yes, thank you. The other part of orange is just big. Oh, I love that. Oh, I love it. Okay, it's really just big. So, no need to say. Anyway, the nutrient inside too little. Too little. Yeah, you're right. Okay, that's brilliant. Okay, so we're done with the first part. Page 36 and 37. Look at page 36. You will see what looks like a tree. Okay, on page 36 you see kind of a tree. What this is trying to show you is that of all the living things we know of, we can broadly categorize them into 3 big categories. Bacteria, archaea, eukaryota. These are very big things. But what is more important to you is to know where you as human beings are. Which category do you fall under? Okay, definitely not bacteria. So may I get you to write down, human beings, we are classified under this big category called eukaryota. The word eukaryota means that it has a nucleus. So all the living things under this category have nucleus. Yeah. I think it's called an amoeba. Also can be found inside this category. Plants. Plants are also categorized under this big category called eukaryota. Or your fishes, animals, fungi, anything with a cell, anything with nucleus can be categorized here.
Spider-Man.
Oh, there is
Oh
a-
my god.
Okay, we will slowly ease into the next part of the chapter. Gradually, we will go into the section where we learn how to classify animals. Which I think will be the next lesson. We have 3 lessons this week, right?
Yeah.
Okay?
Yeah, no, he infected the floor.
Okay, in the next part of the lesson, 2.2, how do scientists make sense of the diversity of life? What is the learning objective? Go to page 34. Then you are a little bit aware of what we're going to do. You will learn in this next part of the chapter how to construct and use simplified dichotomous keys in identifying and classifying living organisms or objects. The big word here is a dichotomous key. I do not think you've encountered this before, and that's what we'll be learning in this part of the chapter. To put it simply, in this part of the chapter, you'll be learning how to classify living things. Because actually, there are many kinds of living things. It's so diverse. And naturally, human beings have this natural tendency to want to classify things. Which is what we'll start off this next part of the chapter with. To start off this next part of the chapter, I'd like to ask a question. Why do we classify at all? We classify living things, but why do we even classify non-living things? Like you go to a grocery store, you classify, right? Why do we classify? So many, and everywhere you go we classify. We classify you in class, we classify you across the level, classify you across the school. Why do we classify? Okay, a lot of hands. Yeah, I'll come to you all soon. Okay, okay, start there. OCD, obsessive compulsive disorder. I'm quite sure not everyone who classifies as OCD. But thanks, Mira. Okay, why else might we classify? Yes. Convenience, why? What about convenience? How does classifying make it more convenient? So that you can easily find things. Okay? Yes, Jen? Nara's point? Okay, easier to remember. Easier to remember what actually? Right, okay. You go to the supermarket, can't quite recall where exactly that thing is, but if you recall the categories, you can go straight to the categories. Okay? Yes? Okay, what do you mean by that? What do you mean make things easier to understand? Okay, so Anaya is saying when you classify, you usually classify with some, okay, you also, when you classify, you usually classify with some sort of purpose in mind. Right? There are some reasons why you classify, and these categories could help you understand these living things or non-living things better. Karthik, yes?
Classify then you spend more time in it, okay? If you want an item and you go to a section, if it is, I know not living, spend the whole rest of that, okay?
Okay, sorry, so Karthik, are you saying that if we classify, we spend less time there?
More time.
Why would we spend more time at the supermarket?
If you want an item, but then you think it's a certain category, but then it's the wrong category. You go and search there, you don't find it, you're gonna continue searching.
So isn't that a result of a bad categorization? If you want to look for milk, where will you go? You go dairy section. But if you go to the dairy section, you don't find it there. You find it under the biscuit section, that means the person has a problem, right? Okay, I think if I were to distill out your point, perhaps it's time. For you, perhaps it's more time if it's badly categorized. It's less time if it's well categorized. Any other thoughts? Why else might we want to categorize? Yeah, I want to listen to some of you who are thinking internally. Yes, for me. Oh, okay. So that people don't take inedible things, kind of for their safety, is it? Okay. Give me an example. I'm trying to think of an example here where they don't take inedible. Okay, let's listen to Hongi, yeah? Okay. Okay, so you categorize also to provide information so that they can make accurate decisions also and predictions. Okay, yes, Divya.
What happens for some cooking oil? They go to the local people station. Well, it does say oil there.
Okay, sorry, I had some thoughts over here just now. Okay, maybe who else have I not heard from today? Joshua, you have any thoughts? What else might we classify? What good thing might come out of classifying things? Easier to find things, yeah? Have you been to a supermarket where things are not organized?
Yes,
Like, where have you been? Okay, sometimes random convenience store you don't organize one, right? You want to find things out very hard to find, right? But so far, all the supermarkets I go to, I typically can find what I want to find. Yeah. Yes, Isabel. What, have you been to Don Donkey?
Yeah.
They don't classify.
No, I not think so.
Okay, but their classification also is in a different language. Sometimes in some sections. Okay? Yes, Sarah? Okay, Karen says, interesting, when you categorize and arrange things neatly, you can compare them easily. Yeah? Karen noticed that if you put two milk products side by side, right? You can just compare the price easily. You can compare the eggs easily also. Okay, thank you. We brought up many reasons why we classify. Let's watch a short video on why scientists classify living things.
Froggy.
Okay, may I get you all to keep quiet for the next few minutes?
Imagine going to a supermarket with a short shopping list.
I went by the
Under
frog.
normal circumstances, this task should be simple. But this time, things are different. Everything in the store has been arranged haphazardly. Soap is next to pasta, which is next to jam.
Oh, what?
And it gets even more confusing. Apricot jam is on aisle 10, while raspberry jam is 4 aisles away, wedged between a box of ingredient toothpaste. A simple task that ordinarily would take a few minutes turns into a frustrating ordeal lasting hours.
Let's start take up.
This is only a dream. Our world The diversity of life on Earth makes the variety of products in the supermarket seem trivial. We have given names to almost 2 million different species living today, and estimates of the actual number of different species vary from 10 million to as high as 100 million. They range from tiny bacteria that are visible only with the help of a microscope to whales weighing many tons. Within only a few square meters of tropical rainforest, there may be hundreds of different species of plants, and probably thousands of species of insects. And the number of organisms living today are only a tiny fraction of the number that have lived in the past. Some scientists estimate that 99% of all the plant animal species that have ever existed have become extinct. We humans are only one species in this complex kaleidoscope of life. But we alone try to learn about and understand the other living things that share our planetary home. In part, this is because we are naturally curious about other living things, but it is also because we want to better understand our own position in the web of life. We want to know how we fit in.
Close enough.
Okay, over 100 million different species. You go to a supermarket, also you don't have so many products. That's why scientists need to find a way, be able to organize things so that they can better have convenience to find information fast, so that they can have an easier way to remember things, so that they have an easier time understanding the different characteristics. They save time when you want to search for information in this broad category of over 100 million species. And I think one of the very important points that Garrett brought up is the idea of comparing. When you organize things well, it's easier for you to compare. So why do we classify things? Or how do we classify things?
Is it piece of dairy product?
Yeah, it is.
Oh.
Okay? So, how do scientists classify things? Actually, we classify things the same way that your supermarkets do also. Number one, they classify things using the characteristics. Number two, they also not just classify based on characteristics, they classify them into levels. Let me give you an example. If you go to the supermarket, actually there are very broad categories. There is like the vegetable section, there is the meat section, there's the chilled food section, maybe there's a snack section. The next level of category, let's say now I go to the chilled food section. Within the chilled food, they categorize it into more subcategories, right? There could be dairy products. What else could there be under chilled food? There could be ice cream, there could be... Okay, so dairy products, then there could be drinks, okay, maybe, exactly, so we can go even further, right? So under chilled foods, maybe I should write it down. Under chilled foods, you could have dairy, maybe you have pig and cube, maybe you have cold cuts, all the meats you can find here. Maybe you can also find some cold drinks. And if I go under dairy, I could actually find more categories underneath. I could find cheeses, I could find milk, so on and so forth. If I go under the cheese section, I will find different cheese types also. Here I have a particular cheese type, the blue cheese. Scientists categorize living things the same way. We categorize them based on their characteristics and into different levels. The smaller the level we go, the more specific the characteristics. The higher the level we go, actually the broader the characteristics. Notice that at the very top over here, as long as it is cold, we categorize it under here. Then we start to go into more specific characteristics. I'm going to give you an example right now. This is how scientists characterize categorize living things. We also categorize based on characteristics and categorize based on levels. I'd like you to look at the levels here. You'll find that at the very top, we have domain, supergroup, kingdom, phylum, class, order, family, genus, and you may have heard the word species. You look at the very top, you see the word domain. That is the biggest category we can split all life.
The tree.
Actually, do you notice I've introduced to you the 3 domains of life? What are the 3 domains of life? Can you flip to that particular page? I think page 26. Yeah. That is the biggest category that we can split all living things. Archaea, bacteria, eukaryota. From that big category, we can categorize into more subcategories as we go downstream. For example, under eukaryota, actually we have animals, we have plants, we have fungi. Under animals, we can classify more. We have birds, we have fishes, and we can classify more and more. I'd like to give you an example, just for the wolf. Actually, if you go further up, we could classify wolves under the word mammals. You've heard mammals before? Mammals have fur. Mammals are, a lot of them are warm-blooded, right? Wolves fit under this big category too. If we go one step lower, actually we have different kinds of mammals. We have carnivores, we have, herbivores, we have omnivores. Wolves are carnivores. And so we can group them under other animals that are also carnivores, like dogs, bears, hyenas, jaguars. Scientists classify the same way. We classify based on their characteristics and also into levels. Each level we go higher on, the characteristics get more general as we classify. I give you another example. We look at leopards. Leopards can also be classified. And at the very end, you'll find that leopards are, if you go to a supermarket where they keep living things up, you will find that leopards, jaguars, lions, tigers, most likely will be found under the same aisle in the supermarket. Because they have very similar characteristics. Sorry, I'm very silly. I should just say, imagine you go to the zoo. Okay? Yeah, what I say to the supermarket. If you go to the zoo, you'll find that actually the zoo organizes the animals in a similar way. They will group the animals based on their characteristics and how similar they are. And in reality, leopards, jaguars, lions, tigers, they are similar in many ways, yet different in their own ways. So you will find, if you go to the zoo, they like to categorize these big cats under the genus Panthera. If you were to go to the zoo, you will find them all under the section Panthera. Next time you go to the zoo, go and check the signs are all there. I believe almost time for lesson to end, right? Okay, what time is your assembly out Tuesdays? 9 o'clock, but it's supposed to end at 8:45, something like that. These are this, right? Okay. You know humans can also be categorized? Yeah?
I told you.
Yeah. Have you heard that humans are called Homo sapiens? That is our scientific name. You know that long time ago there were other types of humans? Okay? Okay, I would like to show you how humans are categorized. Homo sapiens. Actually, Homo sapiens, we can be categorized under the category of animals, right? Because we are animals at the end of the day. Chordata. Chordata means have backbone. Humans have backbone, just like many other animals. We are also mammals. notice as I go down the categories, it gets a little bit more specific each time. Humans are also primates, just like gorillas, chimpanzees, monkeys. And actually, long time ago, there were a few other types of humans.
Darth Vader.
Just like how leopards, jaguars, lions, they were kind of similar, there were actually other types of humans. Yes.
Does like races consider different types?
Do races consider different types of humans? No. Actually, all races, we are still one human race. We are still all Homo sapiens. So, it is not correct to think that way. However, long time ago, there were actually different types of humans. For example, there was another type of human called Homo neanderthals, where their characteristics are quite different. They are shorter, but bigger in size. Their forehead is a little bit much bigger as well as their nose. They tend to be found in the colder climates, where it's much colder and you require these features to be able to survive the cold. Okay? But that's a long time ago. And then, I'm not sure what happened. Maybe our Homo sapiens killed them out. Why am I introducing all this to you? Because just like how humans, just like how we classify living things, actually every living thing has a scientific name. We have a scientific name called Homo sapiens. All living things have a scientific name too. You'll find that their scientific name always comes in two parts. Our scientific name is Homo sapien. The tiger's scientific name is Panthera tigris. Okay? All living things have a scientific name. Plants also, animals also have. So what would I like you to do as a tiny little homework? You flip to page, I'd like you to find the scientific name of just any living thing that you are curious about. Go to page 39. Okay? On page 39, a website has been provided to you. I'd like you to find out the scientific name of any animal or plant that you find interesting. And then we will share them in the next lesson. Other than the scientific name, can you also find the common name? That means the name that people would normally say. For example, I do not call you a Homo sapien on every day. I call you a human. Right? For example, I do not call a tiger normally Panthera tigris. Instead, I just call it a tiger. So could I get you to find out both the common name and the scientific name of any animal or plant that you are interested in? And then we'll just share about it in the next lesson. Okay? And you'll find it very interesting. The scientific name is often very, very long. Please don't get up unless the lesson is over or you ask permission. Okay? Okay, please sit down. Thank you. Where's your chair, by the way? Can you sit down? Is your nose bleeding? You need to what? Okay, then please ask me next time. Okay, come, go. Okay, so that will be all. Just one page, and then we'll share the next lesson. Anything that you found interesting. Okay? Yes. Okay, then there's the next part. What is the value of using a scientific name? Okay, will you just think about it? So write your thoughts down. There's no right answer here. I would like to listen to what you think. Why in the world might we want to use a scientific name? When I do just call it a tiger. Okay? Thank you so much. Thank you, class. Same is on the video.